Welcome to the breakout session on the performance root cause analysis of SQL Server in virtualization environment, leveraging Scion IQ powered by machine learning analytics, and vRealize and SQL Sentry. I'm joined by Jim Sikrolis, on the right here, product manager of Scion IQ, and Brian Davis, the product integration engineer for SQL Sentry. So before we begin, I was just curious to know more about you. Can you tell me, by raising your hand, are you a DBA? Anybody DBA here? Okay, cool. How about IT, virtualization admins? Okay. Anybody here represent DevOps? All right, cool. Thanks. Well, so this is how we're going to do it. Basically, first we're going to discuss the machine learning, right? It's an interesting topic in general, and specifically we'll talk about what kind of value it brings to us, and specifically to IT environments and virtualization. We're also going to talk about the problem of managing SQL Server in virtualization environment, and then we'll talk about the solution that obviously that we here jointly working on, and at the end we'll do the actual demonstration for you, how it actually works. So just as part of the introduction to machine learning, I just give you a little bit of my background. So I've primarily focused on application of machine learning to a variety of use cases. I worked in the areas of security, focused Kaspersky Labs. I worked in the areas of speech recognition, human behavior analysis, signal processing. And prior to joining Scion and working on the Scion IQ product that we were talking about here, I have spent 5 years at EMC CTO office, concentrating on application of machine learning to this emerging space of cloud, software-defined networking, and some of the IoT initiatives as well. Right. So from that experience, and the reason why I kind of stepped from academia into basically into industry was because I realized 15 years ago that it's going to be very important, to apply actually machine learning to some of the complex problems that we have as a result of all the data flowing in and things like that. But the value that it really brings, if you think about it, whether you're talking about self-driving cars, speech recognition, and etc., is increasing the productivity for us, right? So let's take a look at this briefly, this chart that we published by Forbes magazine. So what it shows us is that since 2000, there's been a no increase, and in fact decline of productivity in US in this case, right? So what is actually what contributes to this? I'm sure there's many factors, and this particular topic article talks about quite a few of them. But if we are talking in the realm of IT and technology, if you think about all the technologies that we kind of introduced, such as virtualization. I mean, if you talk about drones and refrigerators that output all the data, it's actually kind of hard for a human to absorb all this information, make sense out of it, and actually use it for something productive. So as a result of it, we actually increase complexity while potentially with the goal of increasing the efficiency. However, the tools that we are using today are not up to speed in order to create this productive environment for us. So there's more data flowing in, there's more things to understand, but it's for human, it's very hard to digest. Now let's look at the IT space specifically, right? If you think about it, the IT space is still leveraging pretty much the old tools. In this case, I'm representing the hammer and the chisel at this new emerging space, right? A lot of tools came out of basically a physical environment, right? And they went through the evolution. And while this evolution perhaps does provide an ability to obtain the data from APIs and things like that, that evolution simply doesn't work, because all you get from those tools is a bunch of data, a bunch of graphs and charts that you try to correlate, right? But it's actually what you're missing here is really a lot of insights, a lot of interplay between different types of things and the relationships that are actually in this data that's not exposed to you immediately, just simply because the tools are very limited in that respect. So what's needed in IT space specifically to increase the productivity is a tool that's able to actually give you this type of information. In this case, I'm talking about information and not just plain data, right? So let's talk about the SQL Server environment specifically, right? So based on the data that we have collected as a result of deploying our products, do analysis, and on the data, we actually determined that basically the virtualization environments are very inefficient. They're heavily over-provisioned, right? So what was virtualization about after all, right? So virtualization was, in fact, all about the efficiency. There is definitely, the productivity aspect of it was being able to provision things simply. It's all software-driven. It's extracted from hardware. However, the promise was to also increase the efficiency. We can run multiple workloads on a single device, right, on a single piece of hardware. But unfortunately, not many actually take advantage of this. And the reason for this is, once again, is because we as humans don't actually understand how to leverage it, because it's created a lot of complexity, and we don't have tools that can help us to take that step and make it efficient, right? So the issue is if basically we're not taking step into making an environment take advantage of visualization and efficiency, because we're really concerned about either breaking the performance, reliability, and not really understanding and being proactive about the capacity, right? As far as the questions that are typically would be asked when we try to understand what's going on and when we manage the environment. So how do I actually wrap my arms around what's happening in my environment? So why is my application slow? This is a typical question, also comes up, I'm sure, pretty frequently in your experience, right? And is this a problem in application layer or the infrastructure layer? Am I running efficiently, once again, to my previous point, or am I just wasting money? And being proactive to manage the environment, well, will I run out of capacity? What if I'm going to add more resources? How is it going to impact my environment and the workloads? So if we think about the sort of the circle of the process that we typically go through when we attempt to address the problem that comes down from the user about the application, right? So the user calls help desk, and I'm sure you have a variety of different use cases, but I'm sure this is a pretty common one, where basically the call comes down, there's a backend system that supports the application, it comes down to the DBA, right? So the DBA investigates the issue, and it's not always a straightforward answer, and it involves other layers of the to be involved of the infrastructure, for example, right? So you get up basically network, storage, compute, etc. So you create this war room situation where everybody is starting to pull out the logs, trying to figure out, so who is the blame, right? Who to blame? And usually that blame ends up being at the DBA level, right? And in terms of, it's not an infrastructure, so it must be you, the DBA guy, who has maybe something inefficient in your queries, indexes, go check this out, right? Well, and after some trial and error type of debugging, we attempt to resolve the issue and potentially address it. However, a lot of issues actually come back as a result of not explicitly understanding what's going on. So let's take a look at some of the data that we have about our users that run SciOS-IQ. So it approximately takes roughly around 3 hours and 23 minutes on average to address the issue. As far as the cost, it roughly takes 4 to 8 if there's 4 to 8 performance issues per week, it takes about $4,200 to $37,000 per week to address that problem, right? So it's very inefficient and cost prohibitive. And it's usually a lot of those problems, they come back, right? 20% of them, because we haven't been able to actually precisely track, because we've actually been reactive. So it's always a postmortem analysis, but nothing that we can see in real time and be proactive about it. And ultimately, everybody's stressed. The quality of life sucks, and and then basically it's a stressful environment, right? So can't we make things better? So why is it so difficult? Well, once again, going back to virtualization and going back to this sort of like transition of software-defined world, right? We're trying to make this environment, whether you talk about cloud or virtualization, be application-centric, right? Where you no longer provision VMs and switches and things like that. You provision application clusters. You provision web services, right? However, the tools are siloed, right? So there's tools that storage guys use, network guys use, application guys, and compute, right? And virtualization. Also, the organizations themselves, in terms of from the management stack all the way down, and I'm talking about like, the individual employees, the way they're structured, they also siloed, right? You have organizations that are responsible for storage, for network and such. So all of that prohibits us to understand, actually, and help us understand what's going on really in the workloads, because workload touches anywhere from the user down to the infrastructure and up, right? And the tools today, once again, if we talk about the evolution of those tools, right, they basically obtain the information from a variety of layers at each individual silo level, right? And basically, the tools are typically threshold-driven that fire a bunch of alerts. However, because they're siloed, they prevent us to see the entire picture in a relationship between, like, for example, how is the storage level, actually, latencies, for example, impact the actual application, because those tend to be different as the I/O travels through the network and things like that. It's very difficult to correlate, as I mentioned, application issues to the infrastructure and determine the root cause of the performance issues after all. And as a result of basically the static thresholding, you ended up with a bunch of alerts that become pretty meaningful. We have some of the customers who leverage threshold-based tools, not specifically going into names, and they basically ignore all the alerts because it's basically they're just there. Some of them have 10,000 alerts that remain from stuff that didn't exist in the infrastructure anymore. But who's going to clean them up? There's no time. It's very inefficient. So now let's look at the example of the data complexity that I'm talking about. So if we take a look at an environment with 100 virtual machines, right? This is a very small environment. This is like basically even smaller than we have in our laboratory where we develop SciOS-IQ. So with 100 virtual machines, you're looking roughly at about 2,000 objects. And by 2,000 objects, I mean you have virtual CPUs, you have virtual memory, you have host, you have physical NICs, virtual NICs, switches, data stores. Also, all of that together comes to about 2,000 objects. But the amount of actual data that comes out of those objects, I'm talking about statistical data, right, the metrics, is roughly about 604 million data points per week, right? Now, if we look at the other side of the spectrum, at larger environments with 10,000 virtual machines, the number of objects is roughly about 200,000. However, the amount of data that you have to ingest and analyze is roughly about 60 billion data points. It's simply impossible for a human to see. Like, if somebody says that they have tools that help them to digest that, it's impossible, right? You're missing so much information that's really meaningful, and basically, and the tools that we have today that went through evolution and not willing to revolutionize and completely take a different approach, they basically force you to go through those stressful situations, right? And in most of the environments that you have is roughly about 3,000, let's say. 30,000 objects, I believe, or 50,000, it's still 15 billion data points. It's a lot of noise to a human. So we basically debug as much as we can based on our understanding. But there's so much in the data there hidden that will provide you to be proactive. But the tools basically hide that because of the silos and things like that. So now let's take a look at this particular picture, right? So if you think about it, because the thresholds and the silos of organizations and the tools are measured at different layers, and everybody have their own understanding of what latency should be, etc., we're missing basically a very important information about interrelationships that actually truly provide us ability to understand where the problem is and how the workload operates, right? So what really needs to happen is to have a complete picture. And I'm not just talking about a complete picture or a dashboard that provides you lots of data in a single pane of glass, as most people call it, right? That gives you the charts about storage and network and things like that. No, here is we need basically a system that's capable of understand what's happening at each layer and derive the information versus just raw data points that you have to manually correlate. So this is where basically the need for machine learning that's pretty much enough to automated performance, automation of performance solutions is needed at this point. And if we think about it, what it provides us, basically, is ability to aggregate and analyze the entire infrastructure from a storage layer to application and with the layers in the middle, and all the objects, the number of objects that I just mentioned. Identify and prioritize the issues that are important for you to address, right? Because some of those things, again, going back to thresholds, they're simply meaningless. They're not important. That's why you're ignoring them. So combination of bunch of data, which to us is a noise, and thresholds that generate a bunch of alerts, it becomes a big problem, and there is no way to understand what caused the problem and whether it's important or not. And of course, ultimately, the root cause analysis and recommendations that actually come out as a result of forecasting how that recommendation will actually impact my environment and be proactive about it. Now, I talked about the tools, so let's do a comparison of the legacy tools, whether those tools going through evolution and machine learning tools, SciosIQ specifically. So manual configuration, right? So a lot of tools, and we captured that input from many of our customers that exist today, they require manual configuration. There is a lot of things that some of them require in professional services. They even rise up the price of the tool as it is, right? Reporting that has to be done and all this thing. Well, with SciosIQ specifically, we basically self-configure it, and there is no manual configuration required. So all you have to do is just point us at the vCenter, and it starts to operate, learn your environment, provide you the insight. The threshold-based system, as I mentioned, providing no insight into operation environment, but generate a bunch of noise, and as a result of storm alerts. However, with a self-learning system, it's able to automatically learn the environment and deliver the most meaningful information for you that's meaningful to you with the prioritization and recommendations. And this is like sort of the nirvana that we talk about all the time, as being proactive about our environment, right? And I'm not talking about just in a space of capacity forecasting, for example, right? So those things are relatively simple if you understand the art of data science, right? But actually performance forecasting. How do I know that I will hit a performance problem in the future, right? Versus the reactive approach of the legacy tools that basically tell you about things that whether as a result of alert happened, or a customer calls you, and then you're forced to basically dig through the data and figure out what happened after effect. So again, like legacy tools, those providing you basically raw data that requires you to parse this information, while SciosIQ provides the intelligence with the deep analysis of all the relationships and behaviors, and able to bubble you up the most important information that you like to learn, to understand, to solve the problem. So how do we work? So basically, the foundation of SciosIQ is what we call a topological behavior analysis. So we collect the information from all the layers in the infrastructure, whether it would be network layers, storage, some of the application integration, and compute layers, right? We derive from that data the interrelationships between the objects, such as your virtual machines, your data stores, your virtual disks, your network switches, and etc. And from that information, we actually also derive the behavior of each individual metric of the virtual machine trying to understand the workload behavior at the individual metric level. However, this is where typical anomaly detection tools stop, right? It's a single dimension that basically like CPU utilization, right? And with a single dimension, you still can create a bunch of smart, perhaps, based on algorithm, but still alerts. They may mean a lot, right? So my favorite example to use with a single dimension versus multivariate analysis is, for example, if my heartbeat usually is, like I say, it's 58 beats per minute. However, if it raises up to 155, it's probably a bad thing, right? Well, not necessarily. If you actually correlate that with my GPS location, you might actually realize that I'm actually running and exercising. So that's okay. So there is no need to be alerted about it. So topological behavior analysis, what it provides us ability to do is actually not only learn the behavior of the workload from each individual metric, but also from an interplay. And by interplay, I mean how, for example, latencies and IOPS work with each other for a particular workload, right? How CPU utilization and CPU ready time or virtual memory utilization and memory ballooning behave under different circumstances. And from that, we would derive the anomalies that actually that are different from that interplay of the workload comparing to the stats in its correlation. And once we have found the anomalies that are meaningful in this case, we would derive the actual objects that are involved in those anomalies, determining things like root cause, objects, and impacted objects, and ultimately delivering you recommendations for those problems. And that's something that Jim will demonstrate in a product, how it surfaces itself in our user interface. So as far as the product itself, SciosIQ basically structures, as I mentioned, the structures your view into the environment into 4 important dimensions: performance, efficiency, reliability, and capacity. And in this case, as you can see, hopefully, we're not actually presenting you with the raw information that requires some sort of parsing, analysis, correlation. We analyze the entire environment using topological behavior analysis. We derive the insight for different types of use cases, whether it's efficiency use cases, reliability, capacity, or performance, providing you information about who is the root cause of the problem, or what is the root cause of the problem, and what are the recommendations to address such. Now, as far as the SciosIQ, what it will provide you once you install it in your environment and it starts gathering information and learning your environment is a completely automated approach to understand interrelationships between the objects and its behaviors. It will provide you ability to accurately understand the performance root cause of the performance issues. And with our integration with vRealize, how many, by the way, of you use vRealize Operations Manager? Okay, cool. So by our integration with vRealize, which I'll touch on in a minute, we're able to also inject the information that we derive. So you can have a sort of like still leverage vRealize as your dashboard, but have some of the information in use cases that we address, such as performance root cause analysis or storage acceleration analysis and things like that, surface through vRealize dashboard. And another integration that we are also here to talk about in the SQL environments is integration with SQL Sentry. Right? So SQL Sentry that Brian will introduce to you if you're not familiar yet, but basically what we do, we correlate the SQL Sentry events with the events or issues that we derive. And in context, we were able to provide you a basically deep insight into SQL issues and SQL environments this way. So Brian, would you like to introduce SQL Sentry?
Thanks, Sergey. I saw a couple people raise their hands in the beginning and said they were DBAs. Just out of curiosity, how many of you are familiar with SQL Sentry? Awesome. Anybody use it currently? Couple? Awesome. For those of you who aren't familiar with SQL Sentry provides innovative tools to improve your SQL Server's performance no matter where it lives, whether it's physical, virtual, or in the cloud, whether it's Azure SQL DB, DW, or APS. We cover all that from our Performance Advisor and Event Manager down to our free tool Plan Explorer. In this scenario, we've now integrated with Scios IQ. And so where Sergey was talking a moment ago, the integration and pushing those events up, some of the events that you find in SQL Sentry, now what we've found within SQL Server and any of the issues, we can push those up to Scios IQ, and those will be realized then on the Scios IQ dashboards.
That's right. So this is how, and Jim will demonstrate it for you during the demonstration, but essentially, as you can see, the events that's SQL Sentry insights that they provide, now we're able to correlate to some infrastructure, ultimately delivering what is missing today. Not only the automated analysis, but also correlation of the issues from application perspective. That underscores whether the issue happens at application level, storage level, network, or compute, and whether it's meaningful, because sometimes anomalies can be not immediately meaningful to you, because you may say, like, well, so what? Nobody's calling. Well, on one side it's proactive. On the other side, with this type of integration, we actually can tell you for sure that user does feel the pain, right, before they call. And this is another example that Jim will go through during the presentation. But essentially, you're able to launch in context the SQL Sentry issues with all the insight and references, and ultimately get into the product if you have it installed as well. And as far as the Scios IQ vRealize integration, the way it works once you enable that type of integration, what you can see here, and maybe even better here, is you're able to essentially still leverage vRealize dashboard, or as your dashboard, right? But by configuring this integration, Scios IQ will basically inject the issues related to storage acceleration, performance root cause analysis, and such, and provide you ability to easily to debug them and troubleshoot them. And I think that also the value that is also important to understand, I'm sure you may have that type of question. Well, what about performance root cause analysis that vRealize provides to me today, right? Well, in our experiments, right, vRealize integration essentially vRealize collects a lot of very meaningful data, right, and provide you ability to correlate, right? So if you're looking for a solution to sort of dig into this with your sort of hands, right, vRealize provides all that information for you. The difference here is that Scios IQ actually performs the root cause analysis automatically. So, and you will be able to simply with a click into the events understand who is the root cause, and perhaps validate all the information that vRealize have, how it was determined, and things like that. So now I think we're going to jump to the demonstration. And 1 second. Okay.
Great. Thanks, Sergey. Good morning, everyone. Product management, Director of Science IQ. And we joined the demonstration between myself and Brian, representing the SQL Sentry integration. What we're looking at here is something that Sergey already showed you on his presentation slide, but the President CEO of Science IQ, sitting in the back, calls this the undashboard, right? So it looks probably like no other dashboard that you've, I think, seen or currently using. Sergey referenced that you're probably looking at a stream of tabs across the top of your browser that goes down individual silos, and it's representing a bunch of logs, events, alerts, false positives, stuff like that. You've got to wrestle with and pull a story together to try and deduce what's going on, what's contributing to the performance issue. We do all that stuff automatically for you, and sort of rearrange your world so that you can focus on four very specific dimensions: performance, efficiency, reliability, and capacity. And today we'll just focus down on the performance side. So what we're looking at here is the left topology pie chart here, and it's divided into looking at 3 different clusters, or vCenter deployments: production site 1, production site 2, production site 3. And this beautiful sort of knock view allows you to cue in to the problem that you've got to resolve, or has Scios IQ resolve. So blue is informational, which kind of suggests that you might be trending towards a warning status in terms of an issue. Yellow is clearly a warning that you are trending towards a performance issue if not addressed. And red is the red alert. We've got a performance issue. There's end user latency issues that might be experienced within your environment. So let's go tackle a problem real quick with the IQ. What you'll notice is we go from the high-level topology view that identifies an issue, and we go instantaneously down to the answer. Right? If you look at the bottom there's a recommendation that is leveraging principles of machine learning, understanding interrelationships between the objects within your infrastructure, and tying that together with performance metrics, and coming up with a very precise recommendation on how to solve your problem. So let's look at the problem here. So the recommendation is that there's a clear indicator that the data store is over provisioned. Recommendation is to rebalance the identified root cause objects, if you will. So we've got all the information here on one display. Something that customers get once they install is a couple of profound moments in working with the application after they see the product installed and gathering insight into their infrastructure is this topology issue representation. So this is what we've assembled. This wasn't sort of pre-configured, preloaded, but leveraging machine learning, we understand the subtle interactions between the objects with your infrastructure, and we pulled together this topology issue view. So what are we looking at? After a couple sessions of working with this, you can very quickly start to navigate across the IQ and get a very deep insight to understand what's going on. So if you look at the bottom legend, we've got some pretty powerful icons like the thunder icon and the fire icon. And so if we look at the thunder icon here, we're seeing that SQL 1 is the root cause object. It is consuming the resources of the data store. There's a contention with respect to the data store, and we're seeing that two other objects are impacted here. Bear is a workload, as well as SQL 3 is another workload that is attempting to get served up data store resources, but it's being excluded on account of this root cause object here. So you can quickly assemble the story. You can understand the impacted workloads and decide which workloads should be tied to another data store. You can also get deeper insight if you want to delve deeper to support your decision in terms of rebalancing, or just take it directly from what SciIQ recommends. You can go to this chart. It's basically the blue line there represented the behavior of this performance metric over the course of the day, week, and month. And we understand the behavior. We understand you're running a backup job Friday nights. It's going to put pressure on the system, but it successfully runs to conclusion. There's no other workloads are impacted, for example. And then you've got your fixed threshold products that are firing off nuisance alarms and false positives. We don't do that because we know that this backup application or the virus scan that you're running on Saturday runs every Saturday, and so no need to get concerned about it. But when we do identify anomalous behavior, we will drill down, identify it, and then link it to other correlated events that may have contributed to the issue. So you can just select on this touch-optimized display and get greater insight. So we also discovered that not only is SQL 1 a root cause object, but concurrent with that, there is a VM that was deployed at the same time. So that's a concern. You move over here, we're seeing low page life expectancy. We'll ask Brian to go into the details once I go back to the prior slide. And here, lo and behold, we're seeing some end-user latency issues. Now it's starting to show up on the user's desk, and they're going to be generating help tickets that the help desk is going to have to navigate through and figure out. I'll ask Brian to maybe explain some of the events that we're seeing.
So a couple of things that you see here. The high average wait time per user session and the low page life expectancy both came out of SQL Sentry. SQL Sentry found those, recognized them, and threw out a notification for that. And what you see then, I want that move up. what you'll see coming into Scios IQ then is all of the information that you would normally get out of SQL Sentry. So you get what happened, in this case, high average wait time per user session event. You get when it happened, the object that it happened on, and you also get our full description out of SQL Sentry as to what that entails. And then, I guess I can't do that with that zoomed in. Try on the load page life. So the same thing on load page life, you get the full description, and as you scroll through, you'll see the entire description. You also see links from SQL Sentry as to further details that you could go and find out more information about this. And then at the same time, if you have SQL Sentry client installed on this machine that you're accessing Scios IQ with, you've got a direct link to SQL Sentry. Clicking that link will open up the SQL Sentry client interface and take you directly to the event that happened, allowing you to delve even deeper into the SQL Sentry side of things, find out exactly what's going on your SQL server. But between both of these, now we're seeing the latency on the drives and the data store contention. And now, not only do you have what Scios IQ has collected, you have the deep integration with SQL Server through the events that have been collected via SQL Sentry as well.
Great. Thanks, Brian. So I think, as you can probably see, is that problem resolution time is decreased dramatically. Average performance issue takes about maybe 3.5 hours to resolve. You may have to war room it with 4 to 6 people on average, translating into maybe 20 hours of cumulative time to resolve some of these performance issues. We're doing it instantaneously, and we're going down deep into the MS SQL stack, gaining insight, intelligence with regard to the performance issues there, and correlating it back to the infrastructure. So this is going to reduce the finger pointing, so you can have a constructive conversation between the application or database admins and that of the infrastructure folks. And so once you start to get control over your infrastructure, if you will, you can then move into a proactive mode and look ahead in the future. So with leveraging the principles of machine learning, we understand the behavior of your infrastructure now. And then we can project the behavior into the future like no other company can. Other companies, for example, VMware with DRS, as well as Turbonomics, if there's any users there, using sort of fixed threshold-based schedulers, right, to load balance across the infrastructure. But that's fixed threshold. It's not learning the behavior of the environment, understanding the unique patterns. So we're overlaying our intelligence onto the infrastructure and anticipating what kind of issues you're going to see in the future so you can get ahead of it. So in this case, Friday, tomorrow is going to be a sunny day for your infrastructure, so is Saturday. But lo and behold, we've identified 2 issues that are going to be climbing out and making a nuisance of your Saturday. So IQ, has identified, in real time, performance issues. You just don't have enough, gigahertz. You don't have enough performance on this particular host that's identified here. So we make a recommendation to rebalance it and relocate some of your workloads on other hosts. If you don't take the advice, what you're going to see is that there's forecasted time details. There's going to be some issues at 12:15, 4:36, as well as 1:26 that morning. So you certainly don't want to call from the help desk asking for help to resolve the problem. So we can help you get ahead and manage your infrastructure even more successfully.
Yeah, so hopefully that gives you guys an idea how it operates. And just in conclusion, I think we went over the topic that I think excites hopefully a lot of us. And we would like to understand how is machine learning will help us in the future. So the real value is increased productivity. And with Scios IQ, SQL Sentry, and vRealize, now you're able to increase productivity, run your environment efficiently, finally, and reduce the time to issue resolution. So thank you.
And we'd like to open up for questions. We got a little bit of time. Any questions specific to machine learning or more generally?
Go ahead.
So how does he measure the memory that a SQL server needs in a virtual environment? So for example, like we provision like 40 gigs of memory at the hypervisor level. SQL reserves, the VBA reserves 36 gigs out of it for SQL. It's always consumed at that rate from the Windows perspective. But does SQL Sentry or
Scion.
Is it able to tell like what SQL truly needs memory-wise? I know vRealize is supposed to tell you.
Yes, from a SQL Sentry standpoint, we can tell you what's actually being used, what's reserved, what's being used, and we break that down into multiple different layers within SQL Server, whether it's the plan cache or what have you. And so, yes, within SQL Sentry, we can break that down, and we show you all those different levels.
Will it give you recommendations like, hey, you should lower the memory on the SQL Server? That's really not a...
Yeah, SQL Sentry is not going to give you that recommendation, no.
Yeah, but we do, though. And we do actually provide you a recommendation based on this data. So this is just, yes. This is just an example of how easy you can basically figure it out. Essentially, we provide you a recommendation in terms of how much memory or CPU you really need. So there is, on the side navigation bar, yeah, something like that, right? So basically, what we're able to do is essentially provide a recommendation of whether you are over-provisioned on the CPU side, on the virtual memory side, or both, in this case, leveraging both this, this SQL data and infrastructure data. And this is essentially on the left navigation bar, this is your functions. Yeah, go ahead. Did I answer your question, by the way?
Right. So in this example, you're seeing the current vCPU allocation being 8, recommended vCPU allocation being 1, right? So it's clearly oversized. And we'll do the same thing for vMem utilization. We go from 16 to 1, and that's from an oversized end. As a counterpoint to that, we're seeing that this workload is currently assigned 4 vCPUs, and to maintain end user satisfaction, you need to climb it up to 6 vCPUs. And in the case of vMem, it was properly allocated, so we're not recommending any change in that. And this is leveraging machine learning. We are learning the behavior of the demands that the workload is making on your infrastructure, and we learn it over the course of the day, and we get better daily and weekly and monthly. And so we'll give you precise recommendations in terms of how to rebalance and have the conversation with your DBA. The DBA is asking for a load of resources. Let it run. You can go back to them and say, this is what we've discovered. I'd like to resize. And it could be undersized or oversized.
Question in the back?
Comment and question. I think all that is great. Getting the layer. And the layer I asked about, I think that gentleman asked about as well. So I provisioned 40 gigs, SQL set to use 36. Will your tools, in conjunction with each other, say, by the way, that SQL box, based upon all the weight events, it actually could use 60 gigs of memory, and you should make that adjustment. Are you getting into that layer of analysis, or are you just at the hypervisor layer if you're using the memory that's assigned?
Yeah. So basically, if at the Windows layer, right, it consumes all the memory as the application works, whichever application it is. We will assume that it consumes it all, right? So basically, it is at the virtualization layer. However, we do, obviously, if at Windows layer, if you provision 40, but you truly use it 30, we actually do have visibility into this. However, if the application truly just chucked the whole thing, then we won't see that.
So you got the caches or things like that. Say the caches are always
On the SQL layer, you mean? Yeah, I think it's a SQL Sentry. Mm-hmm.
Sorry, what was that?
I think we were asking that a lot of us can see the PSO is memory and how much good is there, but we don't know how SQL goes all the way up. I think it gives it back at least something else asks for. What we're trying to find out is, can you look into the actual SQL memory itself and tell us this we can drop down that max memory?
Yes. With SQL Sentry, you can do that. You will pull that out of from SQL Sentry. We know that. So within the SQL Sentry client, you could definitely tell that and see that. Yes?
One of the things that you can do to answer Tom's question within the relationship between the two products is right now the Scion IQ is receiving its information through what we call advisory conditions. And those alerts are generated by those advisory conditions. So you can build an advisory condition based on the kind of weight stats that you were asking about, Tom.
Right.
And then alert Scion IQ based on particular types of weights.
That's a customization that user have to do?
Not necessarily.
Right. That's where you guys should be.
Great, thanks for the feedback on that. Yep. Any other questions?
What level of vRealize operations do you need for either one IQ or Symphony?
Yeah, so our integration does not require vRealize at all. So for us to be able to operate, we integrate with vCenter. However, if you do leverage vRealize, we have ability to inject the events into it. And you're talking about so there's no requirement for us to operate, but are you talking about the version or like the level? Yeah, so basically standard. I mean, it's actually any edition because the edition of vRealize. So. Go ahead. Sure. I guess I'll let Brian answer the SQL Sentry part. But from Scion IQ perspective, we just require user-level permissions because we actually don't perform any type of modifications today. We basically collect the information and analyze it, whether it's vCenter or ESXi host. You want to take it from?
For SQL Sentry, going down farther into the database and everything, you do need admin permissions. And if you want to go further and collect the information from your Windows boxes, whether it be a VM or up through the hosts at host level with SQL Sentry, then you do need admin permissions in those cases. No, take that back. You need read permissions to vCenter or Hyper-V for that level. But at the database level and the local VM level, you do need admin.
Any other questions?
Do you think folks find this session useful? Is this something that kind of inspires you maybe to follow up with us and further the discussion to see how we could improve your operations and utilization resources? I see a couple nodding of heads. Great. Okay, good. Really appreciate your time. Thank you.
Thank you.